Dr. Joshua Aura teaches quantitative analysis, business mathematics, and advanced papers at the advanced level, including BDA, which is business data analytics. So today we are here to talk about BDA, not BDA, but business mathematics, which is a paper in ATD2. And then, of course, we have a quantitative analysis, QA, which is a paper at the foundations level. These papers have always disturbed the students, and yet they are very, very easy papers. They borrow quite a lot from what was covered in high school, For example, if I share my screen here, ladies and gentlemen, you'll be able to see a nice setup. Yeah. So if I share my screen here, yes, like now this is a paper that was tested in April 2024, ATD level 2. So they gave us, it was a morning paper, ATD Business Mathematics and Statistics. Very nice paper, really. And I would want us to just look at one question to connect what I'm telling you that I mean. Some of these things, you did them in high school. Look at question number 40. So question number 40, they are telling us question number 40 ATD, they are telling us the revenue and the marginal cost function of product Z. Product Z is given by, so we have there revenue equals minus 2q squared. So R equals minus 2q squared plus 150q, and then they have given us marginal cost equals who? Minus 2q plus 15. Marginal cost is minus 2q plus 15. And then they want us to derive the profit function for product Z. So now, good students of mine, how do we get profit function? To get profit like this, we normally take the money coming in, what we call revenue. So we normally take revenue minus all costs incurred. So then our profit here will be equal to, I don't have a problem with revenue. Revenue already I have, but cost, I don't have cost. Whatever I have here is marginal cost. Now, there is some important concept that I would want you to appreciate. You know, we have what we are calling here marginal costs. So these marginal costs are the incremental cost per unit. They are the incremental cost of producing an extra unit. So they are very tiny, they are very minute. Anytime you are given marginal cost and you want to change them to total cost, what do you do? To get total cost, we always sum the marginal cost. Anytime you are given marginal cost and you want to get total cost, you shall always sum all the marginal cost that you have. So this is a very important symbol. This is an elongated S for what here? For sum, which basically is a symbol for what here, somebody? For integration. This is a symbol for integration. It's a symbol for integration. It's a symbol for integration. In high school, we did a concept that we called what here? We called integration. All right. And if you're able to remember the formula, whenever you are given here to integrate ax raised to power n with respect to dx, whenever they tell us to integrate ax raised to n with respect to x, what is the rule? The rule of integration here tells us that we need to come and increase the power by 1. You increase the power by 1, you increase the power by 1, and then you divide by the new power. You divide by the new power plus what we call k. In high school, we used to use C. C for constant, C for constant, C for constant. So anytime they tell us to integrate, formula of integration, to integrate is to add, to integrate is to increase. So whenever they tell us to integrate, we shall increase the power by 1, and then you divide by the new power plus k. Here we shall be using k because to us in accounting, C stands for cost. So k is the constant of integration. And I would want to be really very good here by looking at a few examples. So if you're told here to integrate, you are told to integrate, for example, 7x raised to power 6 with respect to x. So if you're told to integrate 7x raised to power 6, how will we be able to integrate this? To integrate, I've given you the formula. What do? I will increase the power by 1. You increase the power by 1. So increasing the power by 1, this will be 7x raised to power 6 plus 1. 6 plus 1 gives me 7. All over the new power, which is 7. All over the new power, which is 7. Plus, of course, we must always have what we call the constant of integration. Plus the constant of integration. So, ladies and gentlemen, if I simplify this a little bit, I will end up getting what here? X raised to power 7 plus what we call what here? Plus what we call k. Plus what we call k. So please, if you give me a few minutes, I will be able to come here and integrate some other functions. What if, for example, someone tells me to integrate just 5x? Talk of 5x alone with respect to x. With respect to x, we write like this, although in accounting, this is not very important. We like, in this case, you're having it silent. So if you tell me to integrate 5x, the integral of 5x, please listen, you know there is an implied raised to power 1. There is an implied raised to power 1, which is silent seated on this. All right. So in this case, we are saying that this one, the way it is originally, there is a power 1 there. So, and remember, integration is all about increasing the power by 1. So if I increase this power by 1, I will get 5x what here? I'll get 5x squared. I will get 5x squared. So 5x squared, we divide by the new power plus the constant of integration. Plus the constant of integration. Constant of integration must always be there. So then this and this gives me 2.5. 2.5x squared plus k. So now I can double underline like this. I can double underline like this. For those of you who are following us online, on Facebook, on YouTube, on LinkedIn, we are reaching out to you from RCM College. Would want to welcome all of you to come and study with us. If you're looking for, a great partner in this CPA journey, RCM College is your perfect partner. We shall be able to work with you in this journey from the time you are beginning level 1, ATD, to the time you finish this entire CPA. And we are very modest in our fees. Our online classes are quite, affordable. They are going for 4,800, in this case here, per paper. The physical classes are a little bit expensive. They go for 8,000 per paper. Why do we charge 8,000 for the physical classes? It's because, you see, we're going to give you access to our facilities now here. You can come here physically. And then on top of that, we shall give you access to our Zoom classes. Whenever you need to attend Zoom classes, you attend. We shall give you access to our videos, and we shall give you access to our notes. So if you're interested in joining us, ladies and gentlemen, joining this winning team, you need to come and simply call us. Our number is 0793 555 000. That's our number. 0793 555 000. 0793 555 000 is our number. You join us. You get, in this case, here to learn, and for sure you shall grow. For sure you shall grow. For sure you shall grow. So get back to our business of integration. Now, ladies and gentlemen, what if, for example, you are told here to integrate, 7x plus, for example, 3x squared. It doesn't matter how many times you want me to integrate. I'm going to integrate one term at a time. And to integrate is to increase the power by 1. So if I increase this power by 1, there is an implied 1 here. So it will be 7x raised to power 2. All over the new power, which is 2. Plus, ladies and gentlemen, with your help, I'll be able to integrate this 3x squared individually. So I will grow the power by 1. If I grow the power by 1, I will get 3x raised to power 3. Because you see, it's 2 plus 1. And then I divide by the new power. The new power is this 3 that I bring down here. And then I'll come and say plus what here? Plus k. I'll come and say here plus k. K must always be there. And then you simplify. So this and this gives me 3.5 x squared. This and this. So we have here x cubed plus k, like that. Now, ladies and gentlemen, what if, for example, you get this new example where someone tells you, hey, integrate just 8. 8, which is a constant. Integrate 8, which is a constant. Unlike differentiation, where constants disappear. In differentiation, constants disappear. In integration, we are adding things. So in integration, there is no constant disappearing. So in integration, what happens, if you integrate this, it will take the variable, which is 8x now. It takes x. It takes the variable of integration. So it's going to be 8x plus k. It's going to be 8x plus what here? 8x plus k. It's going to be 8x plus k. 8x plus k. Now, my good students, if, for example, somebody gave you something like this, integrate 10x plus 100. Integrate 10x plus 100. I love this because it's very popular in our exams. So if someone tells me to integrate this 10x plus 100, this is what is going to happen here. I will end up getting 10x raised to a new power. How do we get this new power? We normally take the old power, which is 1 plus 1. So 1 plus 1 gives us what there? 2. So this becomes 10x. Remember, I told you the way this one is seated, it has an implied 1 there. If we apply now our usual integration formula, it will be 1 plus 1, which is 2, divided by the new power, which is 2. Plus this is a constant. What is the rule with constants? They absorb the variable. They always absorb, on integrating them, they absorb the variable. So then this will be 100x plus 100x plus k, like that, plus k, like that. So that at the end of the day, we shall end up getting, in this case here, 5x squared plus 100x plus k, because you see this and this will give me 5. That plus that will give me 5. So this is the answer like that. This is the answer like that. Now, please, ladies and gentlemen, listen and listen to me very well. Look at the question that you are handling, which is an ATD question. This is an ATD question that came last semester. It was quite an easy question. So they gave us, it's question number 40. It's question number 40. We are told here the revenue and the marginal cost functions of product Z is given by, so we have revenue and we have marginal cost. And then they want us to derive the profit function. And I started by saying, for me to get the profit function, profit is revenue minus cost. But you see, they have given me marginal cost. Instead of giving me cost, they have given me marginal cost. Marginal cost. How do I derive now total cost from marginal cost? What I shall do is to integrate this marginal cost. You integrate the marginal cost. So come here and integrate the marginal cost. To get total cost, we shall integrate. And it goes really like this. This is how it goes like. Whenever you are given any total, like total cost, and you want to get marginal cost, this way, from total cost to disintegrate total cost to marginal cost, this way we differentiate. This way we differentiate. This way we differentiate. And then now when you are given marginals and you want to derive them to total, this way, what do? We integrate. This way 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 we integrate. We integrate. So from marginal to total cost, we are integrating. From marginal cost to get total cost, we are integrating. And I've been able to show you really what you need to do proper integration. So that in this case here, to be able to get, in this case here, total cost, I will come and this is the symbol of integration, the elongated S for sum. So the integration will be minus 2q plus 15. So therefore, my total cost will be, there is an implied 1 there. So this one here will be 2q squared over 2. Because I'm growing the power by 1. This one is a constant. So whenever it's a constant, it takes, upon integration, it takes the variable of integration. Here the variable is q. So then this one here will be plus 15q. Plus 15q plus, in this case here, a k, which is a constant of what here? Which is a constant of integration. Which is a constant of integration. Which is a constant of integration. Now, ladies and gentlemen, remember we are giving you these classes from RCM College. RCM College is your #1 college in terms of CASNEB matters. For those of you who want to join us, don't hesitate calling 0793 555 000. It is 0793 555 000. We continue here. Now listen. So then this one here will end up being what here? My C will end up being minus q squared plus 15q plus k, like that. Because this and this will cancel out. But now there is one unique thing you must always remember. This k is a constant of integration. But in terms of cost, the k now becomes a fixed cost. It becomes a constant cost, which is what here? Fixed. So you're saying in the cost function, k represents the constant cost, which is also known as what here? Which is also known as the fixed what here? The fixed cost. Which is also known as the fixed cost. Which is also known as the fixed cost. And this examiner was quite a nice examiner. He gave us this fixed cost. He told us, if you look at this, he told us that the fixed cost is what here? He told us that the fixed cost is what here? He told us that the fixed cost is 20,000. But now remember that our marginal cost is in shillings thousands. So this 20,000, you must chop 3 zeros for it to be compatible. So our fixed cost is 20,000. And we are saying that we must chop these 3 zeros like that. We must chop those 3 zeros like that. Therefore, our cost will be equal to minus q squared plus 15q plus 20, which is my k there. So this is the cost function. This is the cost function. Now, once I get the cost function, then it will have to hit my head somewhere. That what this examiner wanted me to derive is not just the cost function. The examiner wants me to give them the profit equation. So the question is, how do we get this profit equation? Ladies and gentlemen, to get the profit here, we've just said it is revenue now minus this cost. To get profit, it is revenue minus cost. My profit will be equal to revenue, which is minus 2q squared plus 150q. You have to put this in brackets, or else you get a 0. Minus open brackets, minus q squared plus 15q plus 20, like that. Plus 20 like that. So we are putting the respective functions in their brackets. Otherwise, you will get an entire 0. And then you go ahead and open brackets. So when you open brackets, what do we have here? When you open brackets, ladies and gentlemen, whenever it's just a positive outside, remember here there is no sign outside. So it's always implied that in the absence of any sign, you have a positive outside. So with this positive outside, whenever you're opening brackets, then the terms here will not change their signs at all. So these two terms will remain. It's minus 2q squared plus 150q minus, but now look at this. We are tackling now terms where we have a minus outside. Now with the minus is dangerous. All the terms inside here will have their signs changing. Minus is dangerous. All the terms here now will have their signs changing. Like now this was minus, now it will become positive q squared. This will become minus 15q. This will become minus what here? Minus 20. This will become minus 20. Minus 20. And therefore, our profit will be equal to what here? Go ahead and put like terms together. So in this case here, we have this and this. These are like terms. So minus 2q squared plus q squared. That gives us minus q squared. This and this are like terms. So we have here 150 minus 15. 150 minus 15, that is positive 135q. And then now we have this term alone, which doesn't have a like term. So the one that doesn't have a like term, we shall bring it with a sign. So this is the profit. Remember, in accounting, profit will be pi. In accounting, profit will be pi. Profit will be pi. In accounting, profit will be pi, will be given as pi. So in this question, ladies and gentlemen, you can see profit. Now you come and choose. We've said our profit should be minus q squared plus 135q minus 120, minus 20, I mean. So it is here. It is A. Derive the profit function for the product Z. So it is A. The answer is A. And then now 41, they want us to calculate the profit maximizing unit of product Z. So ladies and gentlemen, now what do we need to do here? Now they want us to calculate that particular quantity that will maximize profit. Remember, at the point of maximum here, it's called maxima. At this maxima, this is the quantity that maximizes profit here, profit maximum. At this maxima, there is a turning point. At this maxima, there is a turning point. And at a turning point, if you extrapolate a gradient over a curve at a turning point is always 0. Gradient of a curve. So the gradient here, gradient which is dy over dx at this maximum point or minimum point will always be 0. Will always be 0. Will always be 0. Will always be 0. Now listen, and listen to me very well. What do they want us to maximize? They want us to maximize profit. They want us to maximize profit. And for us to be able to maximize profit, then we must use differentiation. Because differentiation is the one that talks about what here? Gradients. Is the one that talks about gradients. So here we must now introduce the concept of what here? Differentiation, to be able to get quantity that maximizes the profit. So then we need to study a little bit this concept of differentiation. This concept of differentiation. How do we differentiate? Differentiation is all about gradients. It's all about rates of change. So whenever we are given a function like y equals ax raised to power n, how do we get dy over dx? Dy over dx. So whenever you're given here ax raised to n, to get dy over dx, ladies and gentlemen, this is normally what we do. In terms of differentiation, which is the opposite of integration, anytime you're given this kind of a function and you're told to differentiate, then we'll talk of NUX. The formula is very easy, like the Nakuru thing, NUX. So NUX into a new power, and to get the new power, because things are disintegrating here, to get new power, we normally deduct 1. We normally deduct 1. To get the new power, we shall be deducting 1. So if, for example, I'm not dealing with this, I'm just giving you a few examples here, pointers here. If, for example, you are given like y equals 7x raised to power 5 or to power 6, and then somebody comes and tells you, hey, please differentiate for us dy dx. What is the rule? The rule is about NUX. This power here coming down. When it comes down, it multiplies 7. NUX. NUX means take the power times a. Take the power times a. So in this case here, NUX 6 comes down times 7. That gives us 42 x raised to a new power. The new power will be the old power minus 1. And the differentiation, there is nothing like a constant of differentiation. So therefore, this one, upon differentiating, it will end up giving me 42 x raised to power what here? X raised to power 5. X raised to power 5. Now, ladies and gentlemen, what if, for example, they were to give you something like this? Another one, I hope you guys are taking your notes. Y equals 50x raised to power 6 plus, say, 40x plus 40x. And then they tell you something very simple. Just come and give us dy over dx. Just differentiate. How do we get this dy over dx, ladies and gentlemen? There is nothing that is as easy as differentiation, because differentiation is the next thing. It's about the power coming down. When this power comes down, we will have 300, because it is 6 times 50. So it will be 300 x raised to power 5. Because to get the new power, you take the old power minus 1. You take the old power minus 1. Now, ladies and gentlemen, please listen. What about this one? Where we have 40. You see the way this one is, we say it must be having a 1 that is sleeping on it. It must be having a 1 that is sleeping on it. So this is 40x raised to power 1. 40x raised to power 1. So in this case here, then bring the 1 down, because differentiation is about bringing powers down. When you bring this 1 down, it's going to be 1 times 40, which will give me 40. But now, interestingly, you're going to have x raised to a new power. Can somebody in this case here guess for us? What do you think will be the new power for this? Upon differentiation, I expect to get a new power. What do you think will be the new power for this x? What do you think will be the new power for this x? What do you think will be the new power for this x? What do you think will be the new power for this x? Please try. What do you think will be the new power for x? What do you think will be the new power for x? What do you think will be the new power for x? What do you think will be the new power for x? The new power for x, ladies and gentlemen, here, because it is the old power, which was 1, minus 1, shall be 0. So the new power here will be x raised to 0. And of course, you and I, the two of us, we know that any number, any letter raised to power 0 is always 1. Any letter, any number raised to power 0 is always 1. So this, remember, it's not 40 raised to, it's x raised to 0. So therefore, x raised to 0 is 1. So this will be 40 times 1. Therefore, this one here will end up giving us 300 x raised to power 5 plus 40 like that. Plus 40 like that. And that becomes the final answer. That becomes the final answer. How about this one, ladies and gentlemen? What if you got somebody who just told you that, you know what, my y is 500, that my y is 500, and then he goes ahead to ask you to get dy over dx, to ask you to get dy over dx. So remember, this is a constant. If it was integration, then the constant would have swallowed x, would have swallowed the variable. But for differentiation is the opposite. For differentiation, constants disappear on differentiation. So for differentiation, constants disappear. Constants disappear. On differentiation, constants disappear. Therefore, our dy over dx there will be 0. 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 All right, ladies and gentlemen, please listen and listen to me very well. What if, for example, you were given something like this? What if, for example, you are given something like this? What if, for example, you are given something like this? You have here y equals 100x minus 50. So my dy dx here will be 100x raised to, of course, the one will come down, which will give me 100 x raised to power 0. And x raised to power 0 is 1. And if it's 1, then I'm better, because you see 100 times 1 will be 100. So I'm better off not writing it. Minus, this is a constant. Constants will always disappear on differentiation. Constants will always do what here? They'll always disappear. Now they want us, ladies and gentlemen, to maximize profit. This is what they want us to do. They want us to maximize profit. So they want us to maximize profit. They want us to maximize profit. So how do we maximize profit? Differentiate the profit function. You differentiate the profit function. You differentiate the profit function. This is what we shall be calling the first order condition. This is what we shall be calling the first order condition, FOC, first order condition. So this first order condition, what you shall do is you shall come and differentiate this profit function. So you shall come and say the profit over dq here. because it's Q in question. It's the profit over the Q. So here I will move with speed. So of course I know the 2 will come down. So this will be minus 2Q. Minus 2Q. This Q, of course, I know it has a 1. So it will be plus 135 Q raised to 0. I'll not write that Q raised to 0 here. Minus 20 is a constant. That disappears. The first order condition must always be equated to 0. Because the gradient at this maximum point, is always 0. The first order condition, ladies and gentlemen, tells us that the gradient over a function at this maximum point must always be equated to 0. So this one must be equated to 0. And it is at this point that you must move with speed and give us the value of Q. So move with speed and they give us the value of Q. Move with speed and they give us the value of Q. Move with speed and they give us the value of Q. So here I'll make Q the subject. So it will be minus 2Q equals minus 135. Because you see this one on crossing over, it becomes a negative. So if you ask me, the Q then will be minus 135 over minus 2, which will end up giving me what figure? I have a calculator. So we have here minus 135 divided by negative 2, which gives me 67.5. So the quantity that maximizes profit will be 67. Point what year will be 67 point will be 67 point who will be 67 point who will be 67.5 67.5 will be 67.5. However, it will be very important, ladies and gentlemen, for you. It will be very important for you to ensure that you go to the second order condition for purposes of just proving something. So it will be very important for you to just go a notch higher and they give us the second order condition. How do we get second order condition? Second order condition shall be written like this: D squared profit over DQ squared. D squared profit over DQ squared. That's how you write the second order condition. The second order condition is normally derived by you differentiating the first order. So you differentiate the first order. You differentiate the first order. So you're differentiating this. So when I differentiate this is the first order. This, of course, will disappear when I differentiate. So when I differentiate this, I'll just end up getting minus 2. And remember here, I'm only interested with the sign. If it is positive, you always visualize a bucket that is carrying water. If it's positive, your bucket is carrying water. And if it is carrying this water, then it has what? A minimum turning point. Whenever the second order condition is positive, then you are dealing with a minimum turning point. If it's a negative, like now this is negative number. Whenever it's negative, you always visualize the bucket pouring down water. You always visualize the bucket pouring down water. And if it's pouring down water, then here it has a maximum turning point. So we are writing there that the 67.5 units. 67.5 units is a profit maximizing quantity. I've been able to prove that this is a profit maximizing quantity. It's a profit maximizing quantity. Why? Because SOC is negative. SOC is negative, and therefore it is a maximum turning point. And therefore, it is a maximum turning point. It is a maximum turning point. It is a maximum. So remember, maximum turning point can only maximize our profits. Maximum turning point can only symbolize profit being maximum. And the examiner wanted us to prove that this for sure is a profit maximizing output. So we normally do that proof by looking at the second order condition. Ladies and gentlemen, after that, we go straight away to this. Calculate the profit maximizing units, which you can see there. Don't round off. We take them the way they are. There's 67.5. There's 7.5 units like that. Ladies and gentlemen, after that, now we shall be able to move on to the next question that is very interesting. which happens to be the last question, and then I'll be able to release you guys. Not forgetting to mention that this is RCM Online College. If you have got any friend of yours, any sibling of yours, brothers, sisters, etc., all right, or even sons, daughters that want to pursue this CPA, please always ensure that you recommend RCM Online College to them. Our number is 0793 555 000, 0793 555 000, 0793 555 000. All right. So they want us lastly here to come and calculate the maximum profit. Maximum profit. So you've told us that this is profit maximizing quantity, the 67.5. But what is the maximum profit? Fortunately, we have the profit function. So substitute the 67.5 in the profit equation. So fortunately, we have the profit function. And our profit function, profit equals minus q squared plus 135 t minus this 20. So now our profit will be minus 67 because we know the profit, we know the quantity. So minus, it's 67.5. So it will be minus 7.5 squared plus 135 times 7.5 minus 20. Minus 20. So then you get out your beautiful calculator. You get out your beautiful calculator and they say we have there, open brackets, minus 67.5, you close, you raise to power 2 plus 135 times 67.5 minus 20 like that. So we are getting here quite a huge number, which is 13. Is this figure correct, really? 13,648.75. And don't forget our profit here will be in terms of what here? Shillings thousands. So they want me to return the shillings thousands because our revenue and our marginal cost were in shillings thousands. So they want me to return them. That will be 13,648,750 Kenya shillings, like that. We must have messed somewhere. I don't know why it is here. It's not here. 67.5. Let's again do it. Remember, it's q squared plus 135q, and even the equation is given here. And now they want this maximum profit. They want this maximum profit. Let's repeat. Let's repeat. I must have done it wrongly here. I must have done it wrongly. Let's repeat. Let's repeat. So it is minus 67. All right. 67.5 squared plus 135 times 67.5 minus 20, which at the end of the day will give me 45. Yeah, it's giving me 4536.25 in shillings thousands. So then it will be 4536,250. If you multiply this by 1,000, like that. So that's the profit. That is the profit. That's the profit. Remember, this minus is independent. Actually, I took it wrongly. I should have just squared this 7.5 and then leaving the minus outside there. If you look at the answer given, then we'll be able to tick the correct answer here. We'll be able to tick the correct answer, which is this 4536.25. You can either leave it with the thousands, or in this case, you do what here? You multiply like that. So, ladies and gentlemen, then that now marks the end of our today's session. It has been a privilege, big privilege really, to host you this afternoon. And I'm so sure we shall be able to do much more in future. But the most important thing now, we have introduced day classes at RCM. You simply need to come and visit us at Standbank House, first floor. If you come to Standbank House, first floor, ask for Dr. Joshua Aura. Always ask to see me around before you pay. All right, it will be very good. But of course, I know we are supporting so many of you virtually, the students who don't have to come to anybody's offices. So otherwise, please ensure that you get in touch with our customer care numbers, 0793 555 000. Thank you so much. Be blessed. and bye. Bye. See you another time. Bye. See you another time.